Hello everyone. So next problem is same slope deflection method but with a different problem. Slope deflection method. So here different problem means same single span but having two fixed supports. But here condition is sinking. Okay, sinking support. If this single span is subjected to sinking, so then calculate the final end moment values. That means MAB, MBA. How much? Okay. With the help of slope deflection method, so you have to analyze the final end moments from A to B direction and also B to A direction. Okay. When this single span is subjected to the sinking. Okay, sinking. But here, so he gave sinking of A support is 20 mm. Okay, and sinking of B support is 15 mm. And also, so he was giving like A is rotates by along the clockwise manner, clockwise manner 0.01 radians, 0.01 radians. And at B point it is subjected to anti-clockwise like 0.0075 ACW, means anti-clockwise direction. Along the anti-clockwise direction, so B at B support, okay, 0.0075 rotation is there. Okay, so rotation in the sense here not moment value, radians. Due to this negative direction of rotation, so there, okay, so there theta b equals to, minus 0.0075. And due to this clockwise rotation at A support, development of slope value theta suffix A equal to 0.01 radian. Here also 0.01 radian. This is the given question, and here AB span length is 9 meter equals to L, and flexural rigidity EI value 3.6 into 10 power 4 Newton meter square. And here, so first, what is our first step? Yes, fixed end moments. Correct? Fixed end moment. So tell me M bar AB value 0, you are saying. No, but here he is giving point load also. But I didn't mention in the starting of this problem. See here, 90 kilonewtons, having 3 meters and having 6 meters. Okay, so that means you have to apply minus WAB square by L square formula and M bar BA value plus WA square B by L square. Substitute all the values, so you'll be getting minus 19, A value 3, B value 6, L square, so minus 120 is the answer. So here, okay, we'll get plus 60 kilonewton meter. So you can check. So does it exactly 60 or not? Okay, now next one, coming to step 2. So where fixed supports are there, so their slope values must be 0. Okay, but But in this question he mentioned, so applied radiance values are theta a equals to 0.01 and theta b equals to minus 0.007. Okay, so additionally here he mentioned in the question theta a value, theta b value. So instead of zeros, so you must use these given, okay, so given values. And here MAB equals to M bar AB plus 2EI by L into 2 times of theta A plus theta B minus 3 times of delta by L. Okay, minus 3 times of delta by L. So here observe in question, so sinking concept is there. Okay, sinking concept is there. So before going to substitute all the values in this equation, so I'm going to explain about what is sinking. Okay, so sinking means if in a continuous beam, suppose ABC continuous beam, if A support is subjected to sinking or C support is subjected to sinking and B support. So here I'm taking any okay, subject may any support may under sinking, but here I'm considering suppose if B under sinking. So sinking means support, okay, support position change from okay its original its parent position to the okay original present position, but along the vertical direction. Okay, so there, okay, so there the value of this height equals to delta or this parameter deflection. So here A to B, okay, joined with here single straight line, but here B support okay shifted this position to B dash. So you must okay join this A to this B dash and this C support to this B dash. So I'm joining here. Okay, and this delta value along this span, okay, along this span, suppose I'm considering AB span, so span means between supports gap, between supports the gap is span. So here you have to consider delta value as positive, means left support is at higher level, right is down. And in BC span, observe here, so left span is left support is B, right support is C. So that means here right is at higher level, left is at lower level. So in this kind of okay deflection shape, so you have to consider delta value as negative. Okay, negative value. This is the general rule in sinking concept. Okay, so where sinking and when sinking will occur means, so due to okay, so due to some weaker condition, okay, due to some weaker forces, okay, some effect of some external forces acting at a B support, okay, naturally or artificially. So B is subjected to that natural forces, so the position of B may change from this position to this B dash. Suppose in foundations where columns are present under the okay under the beam span member, so the bottom of the column and bottom of the column area and perimeter of the column area, so surrounding this soil is some okay some portion of soil is in weaker mode, so then there may be a chance of a sinking of column will be happening there. okay, or it may be due to heavy rain attack, or it may be earthquakes, whatever may be. But due to weaker or less bearing capacity of the soil, so then that area, the position of the column may change its original position to the, okay, other position, but along the vertical direction. So this condition, okay, this kind of phenomena is known as here sinking, okay. And so there you have to consider in analyzing of final end moments, so this sinking depth as positive if left is upper hand, and this delta is negative if right is upper hand. Remember in this way, okay. So this is the bow shape line, okay, like remember, like this is a bow shape, and bow left side positive, bow right side negative. This kind of shape you have to observe while you are analyzing the uh, sinking depth values. So here only one support is sinking, so that's why I'm considering only one support, okay. I'm choosing one support here in this concept. So see here, so uh, a sinking depth is 20 mm and B sinking depth is 15 mm. So A position changed from A to, so here A dash, and here B to B dash. But B sinking depth is less compared to this 20 mm depth. Here 20 mm, here 15 mm. And observe these two values. Obviously in 20, 15 is present. Okay, I mean here 15. So from this end point of 15 to, so draw the dotted line along the horizontal direction. So where it is meeting, so there you have to keep one more point also here. So uh, total 20 mm height of the sinking depth. So this 15 mm portion is both B, and remaining 5 mm is extra sinking depth of the A support, okay. Total is 20 and here 15 plus 5 is 20. And so this is the original shape of the beam. This is the original shape of so where I am giving this darken lines. So this is, and compare this shape to so our concept, so where it is matching actually, so this right side portion. So see here along the right side portion, I mean where right is at higher level, so there you must apply delta as negative, okay. So substitute values MAB equals to M bar AB value minus 120 plus 2 into EI value 3.6 into 10 power 4. By length of the span is total 9 meters, and 2 times of theta A value is 0.01, and theta B negative, so minus 0.0075. Next minus 3 times of delta value. Delta I said negative, so value is 5 mm. So minus 5 into 10 power minus 3. Here I am substituting delta as in terms of meters. So that's why I am preferring 1 mm equals to 10 power minus 3 meters. 3 times of delta by L, 9 meters. That's it, close it. So total value, okay, you'll be getting directly, I'm writing here value of MAB. So there, in this case, no need to find out EA theta B value, etc., because already he has given all the values like EI value and EA theta B values. So MAB minus 6.67 and MBA, okay. So MBA value MBA equals to M bar BA, because it is also fixed end moment, so use general formula only. So where there is a hinge support, so there you must apply modified equation, but here fixed support, so that's why I'm using general formula. 2 times of theta b plus theta a minus 3 times of delta by L. M bar ba value is plus 60 plus 2 into ei value 3.6 into 10 power 4 by length equals to 9 meters. 2 times of minus 0.0075 plus 0.01 minus of 3 into minus into 5 into 10 power minus 3 by length equals to 9 meters. Minus into minus ఇక్కడ ప్లస్ అవుతుంది. ఓకే, సో మనం సింప్లిఫై చేస్తే వచ్చే ఆన్సర్ 33.33 MBA value. Okay, next I'm giving the drawing. So here 93 and 6 meters. So this value minus 6.67, so negative left side upward, so 6.67, and here B support 33.33, so right side positive means compulsory upward. Here I'm following this left right minus plus plus minus, so left side negative up, so here first one up and here D for down. And from B to A I got my plus, so right side plus means upward only, but compared to 6.67 it is bigger, so 33.33. so next join these two. Okay, and then after you have to find out maximum bending moment due to this point load. So MAB maximum equals to WAB by L. So here W equals to 90 and 3 into 6. So total 180 value. So 180 compared to 33 it is higher. So peak of this value is 180 higher above this. The linear relation because of point load, and shade the uncommon area. So that's it. So this is about beams with sinking conditions. Beams with sinking condition. Once again I'm repeating here about the sinking process. Suppose ABC, in ABC span ఒకవేళ B సపోర్ట్ అనేది సింక్ అయింది అనుకోండి, సో అండ్ సో డెప్త్, సో అప్పుడు B పొజిషన్ చేంజ్ అవుతుంది. చేంజ్ అయిన పొజిషన్ ఏదైతే ఉందో దాని నుంచి మనం ఇలా డ్రా చేసేసుకోవాలి ఎండ్ సపోర్ట్స్కి లైన్స్. ఓకే, ఇలా డ్రా చేసుకున్నాక మనం అబ్జర్వ్ చేస్తే ఓన్లీ ఇన్ ఏబీలో అప్పుడు బి లోయర్ అయింది, ఏ హయ్యర్ అయింది కాబట్టి, బట్ ఏ హయ్యర్ అని అంటే లెఫ్ట్ సైడ్ హయ్యర్ ఉంది. లెఫ్ట్ సైడ్ హయ్యర్ ఉంటే డెల్టా వాల్యూ పాజిటివ్ తీసుకోవాలి బోత్ డైరెక్షన్స్, ఏ టు బీలో బీ టు ఏ కేసులో. ఇన్ బీసీలో డెల్టా అనేది ఓకే డెల్టా అనేది నెగిటివ్ అవుతుంది. అంటే బీసీలో ఇప్పుడు బి అనేది లెఫ్ట్ అవుతుంది, అంటే లెఫ్ట్ లో అవ్వడం, సి రైట్ అనేది హై ఉంటే ఇక్కడ డెల్టా అనేది నెగిటివ్ అవుతుంది. సో ఇలా ఉంటే మనం డెల్టా అనేది నెగిటివ్ తీసుకుంటాం, నాట్ ఓన్లీ బీసీ అండ్ ఆల్సో ద సి టు బి డైరెక్షన్. అందుకే మనము ఇలాంటి షేప్ ఉన్నప్పుడు, ఇలాంటి షేప్ ఉంది కాబట్టి ఏ టు బీలో -5 తీసుకున్నాం, బీ టు ఏలో కూడా ఏ టు బీలో -5, బీ టు ఏలో కూడా -5 అనేది తీసుకున్నాం. ఓకేనా. సో ఓవరాల్గా అంటే మీరు ఇలా రామబాణం లాగా గుర్తుపెట్టుకోండి. సో ఇలా బో షేప్. సో ఫస్ట్ మనం పాజిటివిటీకి ఇంపార్ట్ ఇవ్వాలి, పాజిటివ్, దెన్ ఆఫ్టర్ నెగిటివ్. ఇది పాజిటివ్ రావాలంటే, ఈ బో షేప్ రావాలంటే ఆబ్వియస్లీ ఇదే సింక్ అవ్వాలి, అంటే రైట్ సైడే సింక్ అవ్వాలి. సో అంటే ఇలా ఉంటే పాజిటివ్, ఇలా ఉంటే నెగిటివ్. బట్ ప్రిఫర్ చేయాల్సింది ఫిక్స్డ్ ఎండ్ మూమెంట్ లాగా ఒకటి నెగిటివ్ ఒకటి పాజిటివ్ లాగా కాదు. సింకింగ్కి మాత్రం బోత్ డైరెక్షన్స్ సేమ్. ఓకే, సేమ్ మ్యాగ్నిట్యూడ్ అనమాట, అంటే పాజిటివ్ నెగిటివ్ సేమ్ సైన్ ఫాలో అవ్వాలి. సో దట్స్ ఇట్. దిస్ ఈస్ అబౌట్ sinking in single span beam. Thank you.